Welcome to the Explainer. Today, we're diving into a really powerful, data-driven way to make your AI applications better, step by step. Let's get right to it. So if you're building with AI, you are probably wrestling with these exact questions. You're trying to create something incredible, but let's be honest, it can feel like you're stuck in this frustrating loop of just guessing and hoping you picked the right model. And really, the whole idea we're digging into today comes down to this classic quote from Peter Drucker. Making a great AI system isn't some kind of black magic. It all starts with measurement. Because if you can measure it, you can improve it. Simple as that. All right, so we're going to break this down into two big parts. First step, looking at your inputs. And what we mean by that is, how do you even know if your retrieval system, the part that goes and finds the right information, is any good to begin with? Well, there are the usual ways people try to do this. You could use a big language model as a judge, but wow, that gets slow and really expensive. Or you could rely on public benchmarks, but those are generic. We think there's a much, much better way. One that's fast, cheap, and totally specific to your data. We call them fast evals. So what is a fast eval? Think of it like this. You create a golden data set of questions and the exact documents you expect as answers. Then you just run the test. You feed in the questions and see if the right documents pop out. The beauty of this is that it's lightning fast and super cheap, so you can experiment like crazy without breaking the bank. Okay, I know what you're thinking. This sounds great, but what if you're just starting out? You have your documents, sure, but you don't have any real user questions to build that golden data set. It's a classic chicken and egg problem. But don't worry, you don't have to wait. You can actually get an LLM to create really good synthetic questions for you. But here's the trick. You can't just tell it, hey, write a question for this document. You have to train it to think like a real user, to ask questions with the same level of, vagueness or specificity that a real person would. If you don't, you'll get these perfect, overly specific questions that make your system look way better than it actually is. So theory is one thing, but what's really interesting is seeing how this all works in the wild. Let's look at a case study with weights and biases. They used this exact method to evaluate their chatbot. And the results, well, they really show you why this custom approach is so critical. This chart shows you exactly what they found. We're looking at something called recall at 10, which is just a fancy way of asking, was the right answer in the top 10 results? Now look at this. The GINA model, which scored great on public benchmarks, was just kind of mid on their specific data. But the Voyage model, it was the clear winner by a long shot. And they only found that out by running these fast custom evaluations. All right, let's switch gears to the second part. Once you've got your inputs looking good and you actually have people using your product, you need to look at your outputs. You need a systematic way to comb through all those user chats and turn them into a real roadmap for what to build next. I mean, once you get to thousands or tens of thousands of user conversations, you can't read them all. It's just impossible. But here's the kicker. All the good stuff, all the user frustration, all the little hints about what they really want, it's all hiding in plain sight, right there in the chat logs. Imagine your fancy dashboard flashes this big number at you. Factuality score, 0.6. Okay, so what? Is that good? Is that bad? Who is it good or bad for? A single number like this is basically useless. It gives you no clue why things are happening. But watch what happens when we break that same number down by what the user was trying to do. All of a sudden, you have a roadmap. You can see, wow, we are crushing it with contract searches. But for any kind of time-based question, we're a total disaster. Now you know exactly where the fire is. And the process to get this insight is actually pretty straightforward. It's just 3 steps. First, you extract structured data from all that messy chat text. Then, you cluster similar conversations together into groups. And finally, you analyze your performance metrics across those different groups. And this is what that first step, the extraction, looks like in practice. You're turning those chaotic chat logs into what's basically a clean, structured spreadsheet. Once you have this, you can slice and dice the data just like any other data set to see what people are doing and, more importantly, where they're getting stuck. So once you have these segments, this is where it gets really powerful. You can use a super simple but effective framework to decide exactly what to do next. It turns all that analysis into a concrete action plan. You just map your feature usage against its performance. It's brilliant. If something is used a ton but performs badly, well, that's a 5-alarm fire. You have to fix it now. If something works great but nobody's using it, they probably don't know it exists. You need to educate users. And if a feature is barely used and also stinks, you can probably just ignore it. And when you tie all of this together, the input evals and the output analysis, you create this amazing data-driven roadmap. It's a virtuous cycle. You're constantly learning and getting better, fueled by real data from your users. So let's boil this down. For your inputs, what are the big takeaways? First, ditch the generic benchmarks. Build fast evaluations on your own data. Second, get your retrieval right first. The smartest LLM in the world can't help you if you're feeding it the wrong documents. And finally, if you don't have users, kick things off with synthetic data. And for your outputs, once you have users, it's all about looking at their data. Pull structured info from their conversations, group them into clusters to see what they're really trying to do, and then compare your performance across those groups. That is how you make decisions that have a real impact. See how these two pieces fit together so perfectly? Fast evals give you the power to test your ideas very, very quickly. And the structured analysis of your outputs, that tells you which ideas are actually worth testing in the first place. This isn't just a recipe for building a good AI product, it's how you build any great product. This entire framework is designed to move you away from just guessing and into a world where you are actively measuring and knowing. It gives you a clear path forward. So the only question left for you is, where are you going to start? What's the very first hypothesis you're going to go test?